Welcome to our deep dive into path tracing today. We'll explore what path tracing is, its benefits, and how you can harness its power to create breathtaking visuals in your projects inside Unreal Engine 5. Path tracing is a rendering algorithm that simulates the physical behavior of light, tracing the paths of rays as they interact with surfaces. This method captures effects like reflections, refractions, and global illumination, resulting in images that are incredibly realistic. So now I'll just directly go to Unreal and explain it there, rather than yapping for hours. I'm using this scene to demonstrate reflections with path tracing. First, let's make sure path tracing is enabled in the project settings. I'll also enable Lumen to show you the difference. Here I've enabled path tracing. Now I'll close project settings and switch the lit mode to path tracing. You'll notice the progress bar at the bottom. This means Unreal is still processing the scene, and it'll take a moment to fully render. We can also tweak path tracing settings inside the post-process volume. Search path tracing in Details panel. Here, enable max bounces, samples per pixel, and emissive materials. Also, if you want to control exposure in your scene, enable max path intensity. To load the scene quickly, I'll set samples per pixel to 200. This will make it render faster, but you might notice some noise and artifacts in the preview. The denoiser is enabled by default, so some viewers might not notice the difference. But let me switch it back to Lumen to compare. Now you can see the wood surface is reflective, but the reflection isn't as accurate as path tracing. Sorry for the cut. My recording got corrupted. But as I was saying, Lumen's hardware ray tracing only traces one bounce per ray by default, which means reflections don't capture multiple light interactions. If needed, you can increase the reflection bounces in the post-process volume to improve accuracy. But even then, it won't match the full realism of path tracing, which traces unlimited bounces for much more accurate lighting and reflections. And now with path tracing, the reflection looks much better. But the samples per pixel are still low, so let's increase it to 2048 for a cleaner and more accurate result. Increasing samples per pixel to 2048 will give us a much cleaner result, but keep in mind, it'll also take longer to render. I can also enable reference atmosphere and reference depth of field in the path tracing settings. Reference atmosphere enhances sky and fog rendering, but in an ArchViz scene, it won't make much of a difference unless you have atmospheric effects. Reference depth of field improves focus blur accuracy, but for architectural visualization, it's usually not needed unless you want a cinematic look. Alright, now let's move over to this spot and take a look at the reflection on this object. And now, we can see the reflection of the wall painting and the pillow. First, let's check how the colors appear inside this object. In lit mode, the painting looks darker, and the pillow's color has also shifted slightly darker. Now let's switch to path tracing and see the difference. Notice the difference? The painting now looks much clearer, and the pillow's color is more accurate, without the darkening we saw in lit mode. To clear up any confusion, here's a real video of a turtle's reflection on water. Notice how the reflection looks natural and accurate, just like how path tracing handles reflections in Unreal Engine. You might be wondering, if path tracing is so accurate and realistic, why do people still create mods to improve realism in games? The main reason is that most games don't use path tracing in real time. Instead, they rely on rasterization or hybrid ray tracing methods like Lumen, which approximate lighting for better performance. Even when games include ray tracing, they often limit things like bounce count, sample rate, and shadow accuracy to keep performance manageable. You might be wondering, how does Reshade make games look more realistic? Well, Reshade isn't actually a full ray tracing solution like path tracing. Instead, it uses screen space techniques to simulate advanced lighting effects without tracing actual rays. That means it only works with what's visible on your screen, rather than simulating how light realistically bounces and interacts with the entire scene like path tracing does. Speaking of mods, I have to give a shout out to Digital Dreams on YouTube for their incredible Red Dead Redemption 2 mod showcase. The level of detail they achieved is insane, and it really shows what's possible with the right tweaks. But of course, even with amazing mods, hardware ultimately determines how far you can push realism, and that brings us to GPUs. Let's see how different cards handle path tracing. Alright, let's start with NVIDIA's RTX series. NVIDIA was the first to introduce real-time ray tracing in 2018 with their RTX 20 series, using dedicated RT cores to handle ray calculations separately from shading. Over the years, they've refined this with better denoising and upscaling like DLSS, making path tracing somewhat playable, at least on high-end cards like the RTX 4090. And with the RTX 5090 expected to push even more raw power, we might finally see real-time path tracing become more practical. Next, AMD entered the ray tracing scene later with their RDNA 2 GPUs, starting with the RX 6000 series in 2020. Instead of dedicated RT cores, AMD uses ray accelerators, which speed up certain calculations but still rely heavily on the shaders. This works fine in optimized games, but for something as demanding as path tracing, AMD cards usually fall behind NVIDIA. And then there's Intel Arc, the newest player in GPU ray tracing. Their first-gen Arc GPUs, launched in 2022, actually have dedicated ray tracing units, and their performance in some cases lands between an RTX 3060 Ti and a 3070. But since Intel's drivers are still evolving, real-world performance can be inconsistent, especially for heavy workloads like path tracing. So while all these GPUs support path tracing, real-time performance is a different story. Even the most powerful cards struggle, which is why most games rely on tricks like denoising, screen space reflections, and hybrid rendering instead. We've talked a lot about how path tracing works in Unreal Engine, but how close is it to real life? Here's a real-world example. Notice how light bounces, how reflections interact with the surface, and how shadows soften with distance. Path tracing aims to replicate all of this, but it's still far from perfect. Confused? Path tracing looks incredible, but should you actually use it? If you're working on high-end cinematics, architectural visualization, or offline renders where accuracy is more important than speed, then yes, path tracing is the best choice. You get true-to-life reflections, accurate global illumination, and soft shadows that look incredibly realistic. But for real-time applications like gaming? Not really. Path tracing is extremely demanding. Even with top-tier GPUs, performance takes a massive hit, making it impractical for anything that needs high frame rates. However, with AI upscaling techniques like DLSS and FSR improving rapidly, we might see a future where path tracing becomes more viable in real-time games. Oh, and by the way, no, I wasn't sponsored by NVIDIA in my video explaining Lumen, ray tracing, and path tracing. But hey, if NVIDIA feels generous, they can always send over a 5090. I wouldn't mind. Anyway, that's where things stand right now. Path tracing delivers incredible realism, but for real-time use, it's still a challenge. Maybe AI upscaling will change that. Or maybe traditional rendering will stick around for a long time. Also, a huge thanks to everyone who supported me on Gumroad and Ko-fi, Hong Sung-hoon, Sona Dogan, Neil Hopley, Spawn3D, Temisferry, Abdul Rawouf, Go, Richard Webb, and Niels Leslie Pringle. I really appreciate your support. What do you think? Will real-time path tracing become the norm? Or is it still a distant dream? Let me know in the comments. And as always, thanks for watching.